Okay. Uh, is the stream on? Let me have a check. Uh, okay, looks good, I believe. Cool. Okay, so here we are again. So of the GCSE paper one, the non-calculator is tomorrow. I believe it's the morning. And so yeah, I thought today we'd do a revision stream. To basically just cover. So these questions I've compiled 25 questions which really routinely come up in lots and lots of non-calculator papers. So these questions, I guarantee a lot of them, you're going to have something very, very similar in your paper tomorrow. Questions that keep coming up. And so the idea is kind of predicted, right, in a way, that the same topics and sort of questions will be on your paper one. And so the idea of it, I think the best, what makes the most sense is to go over these sort of questions, answer them, see how you approach it. And yeah, should any if you struggle with anything now, I think now's a good time to go over it. But at this point, hopefully, you should have revised a lot of the topics, and you really should. And at this point, when you go over these sort of questions, you should be pretty much instantly thinking, "Oh, I know how to do this. You have to do this, this, and this." So the idea is to make sure to, if anything that anyone is a bit stuck on or a bit lost, if you look at any of these questions, particularly on the higher tier, you should have a look at this, right? It's a good idea to go through these sort of questions. See, as I said, I picked out 25 questions that I think, well, what I've seen, not just what I think, but what I've seen very, very, very often come up on non-calculator. Um, and yeah, and so how this is laid out is obviously the question now. So this is mainly going to be targeted at higher tier, but this is good for both tiers because the first few questions, obviously, and this is laid out like a normal, like almost like a paper, right? Easier, difficult questions, lower grade ones, and it goes all the way to the grade 9 at the end, like a normal paper. And I think this is good for both tiers because when you do a higher paper, I feel like with foundation, I feel like a lot of students get a bit tripped up on the later parts of the question. Well, these questions on, but and you'll see here. So the way it's laid out is foundation and higher. So these are the top. These first few questions are going to be foundation and higher, and then obviously the later part will just be higher. But it's even good for foundation because these are the harder, higher end of the paper that these students often struggle with. So it's going to be a much use for foundation as well to look at the stream and look at these questions as well. So yeah, I think this stream should be of very good use. But yeah, as I said, I'll try and keep an eye on the chat. Obviously, anyone has any questions as they go along, that's the whole point of this. Or even after, just try and reach out. I'll try the best I can answer. But yeah, I think I'm going to stop waffling and also waffling. So the last thing is obviously the grade, not the grade, but like the tier is here. So if your foundation are higher, that's to pay attention to. But if you're higher, every question, this is going to be like a higher paper, essentially, just with the common questions. But if your foundation, keep a lookout here. And the marks will be here. And the paper it came from to show that it's from a past paper will be here. There's some that are taken from a like a topic question pack. However, they're very, 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 very similar in style to an exam question. So they're all exam questions essentially. Okay. So with that said, so these are the questions again to reiterate that will most likely come up on non-calculator. Okay, that often do. So it is of very, very good use to look at this. If you want to go try the questions out first, pause it or whatever, and then see what I do after. But yeah, uh, uh, with that all said, I'm gonna try and get through this now. I've started a bit earlier, so I'll just stream as normal. Obviously, to give more time afterwards or whatever. The people that watch the stream will decompress or whatever after, so people can revise or whatever after it before the exam tomorrow. Cool. Okay. I'm also gonna with the aim of. I'm sorry, I will stop waffling after this a bit. I'm not really gonna go too much in depth with the questions like I perhaps do in other ones. The idea with this is really you should have learnt these topics by now. And if you haven't, obviously this should be a wake up to see what you might know, what you don't know, and then what you need to practice. Um, well, today hopefully later on. Um, what's it called? But I'm not gonna. I'm just gonna mainly just go over the method and what you should kind of write and stuff like that, and how you approach it. But you really should be quite familiar with it. I'm not gonna go too much in depth with it. I'm just gonna basically write how you do it, essentially the method. Which so yeah. So I'm not gonna waffle as much. Okay, now I've said all that, we are going to start now. Okay, let's look at the first question then. So, most papers, I believe, will start, and your one will most likely start off with an arithmetic question. For 3 marks, work out this division. And you should have practiced it. And the best way to do division uh, is to, first of all, especially with decimals, and it will be a decimal. 100% if you get this type of question, it'll be a decimals. The best way to approach this is to write it as a fraction. Oh, I'm getting ahead of myself here. Is to write it as a fraction first, because that will make you see where you move the decimals. And yeah, so we're going to need to move this. How do we get rid of the decimals? Well, what we're going to have to times by 100, right? To get rid of both of them. So we're going to have to move both of them to 2 decimal points. And so you times by 100, top and bottom by 100, right? That goes to 846 over 15, which will make our division a lot easier. So divide with whole numbers. That's the idea with this. Okay, so now we need to divide this. So you're going to want to do bus stop method. So 15 over 846. So 15, first of all, you need to check it goes into 8, the first digit. Nope. But then what about 84? Well, you have 15, 30, 45, 60, 75, then 90, but 90 goes over 84, so 75. So how many is that? 1, 2, 3, 4, 5. So 5, 15 goes to 75. So I should put 0 there because it doesn't go to 8. 5. And then what's the remainder? 75 to 84 is 9. Okay, so now we need to put a 9 here. So then how many 15s going to 96? Wow, 90, and then obviously the next one's going to be 105. That'll go over 96. So the answer here is 56. And what's the remainder from 90 to 96? 6, right? However, that's it. There's no more numbers here, so we're going to have to add a decimal point and then add a 0. Um, so then how many 15s now going to 60? Well, that's bang on 4. Okay. And so the answer to this decimal, well, read the top number. So it's 56.4. And that is your answer because this is exactly the same as our original division here. So that is our answer to this question. So hopefully you should be comfortable with long division or bus stop method or whatever at this point. So that should be that's how you tackle that. Okay, one question two. Again, fractions have come up with which every single paper, and it will be a non-calculator because obviously, if you had a calculator, you just work it, plug it in the calculator. So this will be a non-calculator. I'd pretty much guarantee you. I'll take 99.9% certainty there'll be a fractions question like this. Okay, cool. On both papers as well. Okay, so part A, question 2. Work out this. So it's it's going to look like this. So you're going to have a mixed fraction. So the best thing to do is to firstly write it as a improper fraction, so just a fraction, no number, no mixed. And so how do you do this? Well, you times by the bottom number, add the top. So 2 times 7 is 14, add the 1, 15, and that'll be over 7. Do the same with this, so 1 and a quarter. How do you write that as a fraction? Well, times it again, 1 times 4 is 4, add the 1, 5. So now what we can do is simplify it by adding these two fractions. So 15 over 7 times 5 over 4. So you should remember with adding fractions, you need to make a common denominator. But the way, there's no obvious one, so we just times by the denominators. So 7 times 4, that's going to be 28. So both fractions have to be out of 28, okay? Okay. So now we're going to need, well, 7 times 4 gets us 28, so we're going to need to times the top and bottom by 4 here. So 15 times 4 is 60. And likewise with here, well, this is 4, so to get to 28, we times by 7 now. So 5 times 7 is 35. And so then we add them. So now we have a common denominator, and we can just add the top. So 60 plus 35 is 95 over 28. And that is your answer. No need to simplify. It doesn't say anything. So there's your answer. You don't need to convert it to a mixed number. That's fine. You can leave it like that. Okay, now for part B. Work out this division. So exactly the same way. We have a mixed number. Firstly, convert it into a whole number. So it's 1 times 5, fraction, sorry. So 1 times 5 is 5, add the 1 is 6. So this would be 6 over 5. So now we want to do 6 over 5 divided by 3 over 4. Make this a bit messy. Well, when you divide, you have to keep flip chains. So keep the first fraction. You have to flip the second one and change to a multiplication, right? A time. And when you time fractions, unlike addition, you can just simply times across. So 6 times 4 times the top number. 6 times 4 is 24. And then times the bottom number. 5 times 3 is 15. Now it says to give us a mixed number. So to convert to a mixed number, so this fraction and a whole number. Again, how many 15s go into 24? 1 out of 15. So then 15, then 15 times 1, 15. And how do we get from 15 to 24? We have to add 9. Okay. So there's your answer to that. So 1 lots of 15 and another 9 gets us 24 here. Okay, so that's a mixed number, but then it's in simplest form, so we can simplify this fraction. You should know that 9 over 15, well, 3 goes into both of them, the highest common factor 3. So divide both sides by 3. Well, 3 goes into 9 3 times, and 3 goes into 15 5 times. That is simplified, so that is your answer here. Okay, 1 3 over 5. Okay, for 2 marks each. Cool. Hopefully that's okay. It should be easy marks and you should have practiced it hopefully. But this should be a refresher if you haven't. Nice marks, and this will definitely come up. This type of question, absolutely. Don't lose easy marks like this. Okay. We're on question 3, and they love asking this type of question. It's only a mark. It'd be pretty simple, but they love asking it, and it's good to check. Okay. So it says use these graphs to solve the simultaneous equations. And yeah, so if you look, the graph, the equations 2 minus 2x equals x, that's here, and 2y is 3x minus 22, identical equations. They're drawn it. So how do we solve them? Well, this happens graphically when they intersect. So when they cross, That is the solution to the simultaneous equations, okay? So when you're given a graph and you want to find when they both are equal to each other, it's their intersection point. So then what we can do then is simply read off the graph. So what y and x coordinate is it? So x is here. So clearly that's going to be 6, sorry, if you just read off the graph here. And the y. So read off the y. And that's going to be -2. So then the solution is the xy coordinate. So that's going to be 6 for x. And let me put that here. 6 for x and y is -2. And that is the solution to simultaneous equations. It's only a mark, but you just need to be able to quickly know they intersect and read off the graph. They love asking this in the non-calculator. They love it. Again, don't throw away an easy mark. Even though it is a mark, you should spot this, okay? Okay, wrong question 4. Again, they love asking transformation questions. Okay, so we are given shape A can be transformed to shape B. Hopefully you can read this, hopefully. This shape A can be transformed to shape B by reflection in the x-axis, followed by a translation with vector CD. Find C and D. So with translations, they love asking you to do multiple transformations. So do them one by one. A very common theme I'm going to keep drilling here is split the question up and do it one by one. Don't try and do it multiple things at once. Don't try and overload yourself and freak out. Break it down and look one by one. So firstly, it says a reflection in the x-axis. Let's do that. Reflect A. This is the x-axis. After this axis here. Okay, so let's translate every vertex. So the idea is to map every vertex. Okay. So try this one. So 1, 2. So then reflect it 1, 2. What about here? Again, 1, 2, 1, 2. And then this one here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then simply connect to form a triangle with a ruler, obviously. That's the best I can do without a ruler. But yeah, that'll be the reflected shape. That's a reflection in the x-axis. But then it says it's followed by a translation. So now we need to translate this into this triangle B here. Okay. So then let's have a look. So a translation is essentially how many units you move left to right, and then how many units you move down or up. So a vector, you can almost look at it like a coordinate. It's like x, y. So where do you move on the x-axis? So how many x coordinates does it move by? Then when it moves down, how many y coordinates or units does it move down? This is a vector like this. It's basically x, y. So don't try and think too deeply about it. So what we do here is with translation, just see how many units it moves. How many does it go across? So let's check. This one obviously goes to here, this point here. So let's check it. It goes 1, 2, 3, 4, 5, 6 units left and 1 unit down. Let's check this one as well. 1, 2, 3, 4, 5, 6, and 1 down. And this is also going to be 1, 2, 3, 4, 5, 6, and 1 down. So that this is the translation. So how do we write this as a vector? Well, like I said with x, y, if you go to the left, it's negative. So units left is negative. So that's -6. And going down is negative on y. See how y goes down, it's negative. So going down by 1 is -1 here. Okay, just know that going left is negative, down is negative, but going right would be positive and up is positive. But here we're going left and down, so it's negative, okay? Which means then if this is equal to CD, that means C has to be minus 6. D has to be minus 1. Okay, hopefully that made sense there. But remember these questions. Hopefully you have practiced them now. They do love asking these type of ones. Do it transformation by transformation. So do the first one and then the second one. Okay. But hopefully that should be that should make sense at this point. Okay, so we are given now. Again, they love asking these sort of net questions as well. It's just something you need to know. So, we are given this pyramid here. We're given some information about the various lengths of the sides. Okay. So it says for part A, draw an accurate front elevation of the pyramid from the direction of the arrow. So the front view. Now, if you imagine it the front view, we would only see this side here, the sixth. That would be the base, and we'll see just how it would look like a triangle. Obviously, look, we would only be able to see this face here of the shape, this face here, this triangle AVB. That's the only thing we could say. We could see if we would see the front. All this other bits of the shape would be hidden from our view. If you imagine we're here, we would only be able to see triangle ABV. And so yeah, so we'll see that this is a triangle with a base of 6. But the height the height we'll see here would not be 5 because this is slanted. Okay, and this does not start for and we would want this straight height here. That's what we'd be able to see. This is the straight height, not the slanted one. So we would only see a depth of 4 here, like a height of 4. Hopefully, it's quite tricky to explain these visually. It's just something you need to like be able to see or picture. If you practice enough of these questions, hopefully it starts to become clear. But hopefully you will realise why this is not the height that we see from here, but this is because this is straight up. Okay, this is slanted, so that's not really the height, the depth you'll see before here. Okay, it's kind of like pitching a tent, I guess. So imagine it is like a peg, and these are like all the little bits of the tent, I guess. Will the top here from the ground really? It's 4, right? It wouldn't say it's 5 from the ground to the top. It would be 4 here because it's straight up. 5 is slanted, so it gives a bit more length than it should do. So kind of picture it like that, I guess, if that helps. So to see that the base across, we'd see a triangle. So a triangle would have the base 6 here. We'd see 6. But the height from the bottom to the top of the floor to the top would only be 4. That's what we would see, not the 5, okay? Hopefully, I've explained that as well as I could. Hopefully, that made some sort of sense. So yeah, so it's a triangle then. Uh, so we'd say triangle ABV. The base would be 6, and the height here, the vertical height here, would be 4. And that's what we're drawing, right? The accurate front elevation. It says accurate. They're giving us a centimetre grid. So each square is a centimetre long. So what we need to do here, look here. Let's draw a base, a length of 6 squares. So 1, 2, 3, 4, 5, 6. So then draw that accurately with a ruler. Unfortunately, I don't have a ruler on me. Well, I do, but actually I'm on a computer, so it's really hard to draw an accurate line. Anyway, so that's a base of 6. You can label it if you want to, but the length but it doesn't matter. Now we know it has to have a height of 4. We've discussed that. but the 4 is acting in the middle. So obviously it's going to be in the middle of the triangle. So 3 centimeters along. 1, 2, 3. It's going to be here. So the top of it's going to be up here. 1, 2, 3, 4. And so now with a ruler, you connect it to each edge. Okay. And if you want to, you can label. Oh God. Oh God. What am I doing? Oh God. There we are. Okay. Computer's messing me about. Okay, so that's 4. So the height would be 4, and the is 6. That's what we would see from the front. Hopefully that made sense. You just need to practice these sort of questions. And yeah. So now for part B, work out the total surface area of the pyramid. Okay, so the surface area. So that is the area of obviously every face. Now, obviously, a 3D shape is just essentially composed of various 2D parts. So notice the faces of triangles, and this is a square base. So if you imagine we hold this pyramid, this shape, in the air, so every side is, and crevice is exposed, we would see 4 of these triangles. Now, the area of the triangle, now think about it. So it told us the area of a triangle now is obviously base times height, half and half. Okay, but what is the height here? Now the height is the vertical height. Now the area of the triangle, the height this time is 5, because whilst the height, this is not the this little height here, slanted. That's the perpendicular height. Okay. The reason it's not 4 is because simply the 4 is not hitting the triangle, so it cannot be the base of one of the shapes. But here, this height here is in the middle of the triangle, so this is the height of the shape. Is 5 of one of these triangles. That's the height. Okay. Hopefully again that makes sense. So again, part A, the reason is this is in real life, the depth we would see would be 4 because it's from the bottom straight up. There's no slantiness, so it's straight up 4 like a tent. But the area of a triangle, the height here would be 5, not 4, because it's actually hitting and crossing the triangle. So clearly, this has to be the height of a triangle, not this, because obviously at the bottom, that's not crossing the triangle. Okay, I hope important distinction. So we've got so this is the base 6 and a height 5. So we need 4 lots of how many shapes are there? How many faces? One here, one here, one here on the other side, and one at the back. Okay. So yeah, so we'd have 4 lots of uh, 4 lots of those triangle fat sides. They'll all be the same triangle. Um, Plus the other surface we have is this square base, and it tells us it's a square base pyramid. Now we know that one of the sides is 6, so all of them are going to be 6. So now we just compute the areas. So the area is going to be 4 times the area of a triangle, which is a half times the base times the height of 5, plus the area of a square, which is 6 times 6. Which is, and I don't have a lot of space for this, but yeah, hopefully it's clear. Okay, so let's work it out. So 4 times a half, well, 6 times 5 is going to be 30. Half of that is 15. Then you times by the 4. 15 times 4 is 60. And 6 times 6 is 36. So then this added is 96 centimeters squared. Remember, it's area, so it's centimeters squared. Don't forget your units. So that is the total surface area of the pyramid. Hopefully that made sense. Again, if you practice your surface area and stuff like that, you should remember surface area is the area of all the faces of the 2D shapes of the thingy, right? The pyramid, the shape. Okay, hopefully that made sense. Okay, we're on question 6 now. And this is a ratio question, and you are absolutely 1000% going to have a ratio question for like this in the paper. Okay, so it says a shop sells packs of black pens, packs of red pens, and packs of green pens. There were 2 pens in each pack of black pens, 5 pens in each pack of red, and 6 packs in each pack of green. And it tells us this ratio about the packs of pens sold, which is 7, 3 to 4. A total of 210 pens were sold. No work how many green pens are sold. So there's important distinctions to make here. So what they told us here is how many pens each pack. So this is just how many pens there are. This is telling us how many packs were sold. So you need to distinguish between the number of pens and the number of packs. Okay. Um. Okay. Well, it says work out number of green pens sold. So we know we were told how many pens are sold in general. So let's kind of work out a way to get that. So they tell us here 2 pens for each pack of black pens. Well, actually, uh, if you let x equal number of if number of no let b sorry that might help. Let b equal the number of pack packs of black, right? Let b equal that. Let r equal number of number of packs of red, and g equal number of packs of green. Well, actually, the number of pens of black, the number of pens of black pens, well, that's still going to be how many pens are in a pack times how many packs there are. So it's going to be 2 times B. So for each pack of black pen, there's 2 in each pack. So that's how many black pens there are. So actually, I write that. So number of black pens is 2B, right? 2 times B. Number of, hope I have enough space. Number of red pens. Again, there's 5 pens in each pack of red. If there are, it's going to be 5 R, right? Because R's the number of packs of red, but we know there's also 5 pens in each pack. So the total number of red pens is how many packs there are times by 5. Because there's 5 pens per pack. Hopefully you can get your head around that. And then the number of green pens is going to be 6G, okay? Because we know there are 6 pens in each pack of green. There are an unknown amount of packs of green, okay? So that's 6G. So that means all of this has to equal 212. Actually, no. I tell you what. There is a way to solve it. I'm overcomplicating it here. I do apologise. I'm going to do this another way. I do apologise if I did throw people off. I think there's a better way of doing it. Let me show. Okay, but the ideas remain the same, right? We know how many pens for each pack. So really, all we need to know is how many packs there are. But they tell us a ratio here. 7:3 to 4. So we know the ratio is 7:3 to 4. So black to red to green. The ratio of black packs to red packs to green packs is 7:3 to 4. However, that is a ratio. That is not telling us there are exactly 7 black packs sold and 3 red, 4 green. That's just telling us a ratio. What we need to do is to make sure is to scale it by some factor x. So if we said 7x, 3x to 4, 3x to 4x, and this is the strategy with these type of ratio questions. This and we pick an x such that this now is black. The number of black packs is 7x, and the number of so number black packs is now 7x. Number of red packs is 3x, and the number of green packs is 4x. Okay, because obviously an example is kind of like a fraction. Say if you had a pizza of 4 slices, say if you had 2 slices, that would be 2 over 4. Now we can simplify that to 1 over 2. But this is saying effectively there were 2 slices of pizza, but you had 1. That's not what happened in reality. In reality, even though they're exactly the equivalent, they mean the same thing. That's not what reality is. There are actually 4 slices and you had 2. Not you had 1 and there were 2, even though they're sort of the same. They're equivalent but not identical, is what I'm saying. And that's what's happening here. There are actually 7x, or an unknown amount of 7 of packs, but this simplifies down to 734 if you cancel the x. But that's not saying there was 7 packs of black pens or 3 red pen packs. But if we times by something else across both of them by a number x, we times by a number x, and this ratio, we can now ensure that this is actually truly the number of amount of black packs. So it'll follow this, okay? So that is the crucial idea behind ratios like this, is to times by a number, which you need to find. We're going to need to find x here to tell us a proper number. But that's the idea. With these ratios, they are not what, that is not the true amount. That's what's telling you a ratio, a proportion, but it's not telling you the true amount. So what you want to do is scale it times by a letter x to give you the proper amount, okay, which you can compare. Hopefully that made sense with this example here. That is the whole aim of this, with these sort of questions, is to use the ratio to tell you to get a number, but we can't get a number here because we have to times by x. Okay, so we know the number of each pack now, but we need to find x to get an actual number. Okay, but it's telling you here. Now we can use this information. We know how many packs there are, but now we can kind of work out how many pens were sold. Uh, because we know there were a total number of pens. Because, like I said before, the number of pens are black. That's going to be how many 2 pens times the number of packs. Okay, because for every pack of black, there are 2 pens in each box. So how many black pens there are is going to be 2 times 7x. Okay, so there's 7x black packs, and there's 2 pens in each. So the number of black pens is going to be 2 times 7x. In the same way, the number of red pens is going to be the number of red packs, 3x, times by how many were in each pack, which is 5. And the number of green pens is going to be 6, times how many green packs there are, which is 4x. Okay. And then we can connect like, well, let's simplify this a little bit. So that's going to be 2 times 7, x is 14, x just times the coefficient. 3x times 5, wow, that's 3 times 5, 15, x plus 6 times 4x, well, that's going to be 24x. And if you collect like terms, add the numbers, 24, 24 add 15, that's 39, add 14, that is 53x. Okay, this is the total number of pens. Hopefully you know why, because these are the number of black pens, number of red pens, and number of green pens. So add them all together gives us how many pens there are in total. Okay, but actually it tells us how many there were in total. 212. So that's telling us our total we've got here, 53x, has to be equal to the 212, which means x then is 212 divided by 53. And so actually this has to be a whole number, really. So yeah, how many 53s go to 212? Exactly 4, right? If you work that out, if you just list the multiples of 53, or do it do it in your head or whatever. This division here, 212 divided by 53, gets you 4. Okay, so that's telling us then, if we times this by 4, this ratio, that tells us how many packs of pen were sold. So now we can work out individually how many green pens are sold. So green pens, I want to, um, I want to make some room here. Okay, so hopefully that is clear. This bit there, this whole bit simplifies to 53x. Okay, oh god, hopefully that's clear. If you just simplify it in collect like terms. Okay, so now we the number of green pens. Wow, that's how many pens there are times how many packs there are. So that's 6 pens, and there are, if you look here, 4x packs, right? G4, 4x. So that's how many packs there are. But actually, we know what 4x is, don't we? Well, we know x is now 4 here. I'll box it here. So 4 times x, so that's 6 times 4 times 4 x here. Well, 4 times 4 is 16. So now we need to work out 16 times 6. And if you want, you can list multiples of 16. 16, 32, 48, 64, I believe. 80, 96. So the answer should be 96 pens. Okay. I want to double check that's right. My mental maths is right, hopefully. Yeah, hopefully that's right. Yeah, obviously, double check that. But yeah, so the answer should be 96 pens. Okay, that's how you approach these type of ratio questions. Okay, so the central idea with this is to make sure you realise that this ratio is just a ratio. It's not the exact amount of It's not the exact amount of how many packs there are. It's just telling you a ratio, like with the fractions. Okay, you have to, if you want to get the true amount of the number of packs, so essentially getting rid of the ratio, but you want to get an actual number times by a number to scale it to give it the true amount. This is kind of like I don't know, like a multiplier, right? So this multiplier gives you how many true amounts there are. Okay. Once you realise that, hopefully it kind of makes sense. I know, yeah, and don't be afraid to use a bit of algebra as well. If you use algebra, if you don't know something, don't be afraid to use algebra. It might make your life easier, believe it or not. But yeah, especially for foundation people, I do realise this is going to be at the very top of the paper. So this is really stretching your algebra skills for like the grade fives, okay? And even for higher tier, can be quite tricky. Obviously, people might have their own ways of tackling it. That's completely fine. Just show my approach if you don't have one already. Okay, that's out the way. Lovely. So now we're on question 7. And these type of questions are typical as well. And this is going to use the idea of using algebra again to represent unknowns. Well, you can do. Okay, so this is a percentage question. Clearly, so the price of a holiday increases by 20%. This 20% increase adds 240 pounds to the price of a holiday. Work out the price before the increase. So we do not know this price. So and we're increasing it by something. So I think the best way to tackle this, if you're unsure, is just let X be the initial, right, the initial price before we apply a percentage. Okay, so it's telling us the price increased by 20, but it's saying the 20% increase adds 240. So that's telling us 20% of X is 240. How do we write 20% of X? How do we write 20% of a number? How do we get that? That's going to be a fifth or 0.2. So not I use a fraction. So 20% equals a fifth. That you should recognise. So this is saying a fifth of X, a fifth times X is 240. Okay. So then how to get X on its own? Uh, because if we get X on its own, that gives us the initial price, what we're after. So what you want to do here is, well, you want to, okay, so fifth X, you're going to want to times both sides by 5, right, aren't you? Because if you times a fifth times 5, that will give you, that they will cancel each other out and you just get left with 1. So that will cancel out the fraction. So times by 5, you'll just be left with, oh dear, what have I got here? X equals 240 times 5. Okay, so now you just got to work out this sum. So again, you can list multiples of 240 if you want to. That helps. So 240, 480, 720, I believe. 960 and 1100, 1100. No, 200, I believe, isn't it? Yes. And that, okay. That should be your answer. I believe it again if my mental maths is right. If you're a bit unsure, so again, this if you're really, really unsure with a certain uh, multiplication, don't be afraid to use mental arithmetic. Use long multiplication, for example. So 5 times 0 is 0. 5 times 4 is 20. So that's going to be 0 and carry the 2. 5 times 2 is 10. Add the 2 is 12. So carry the 1 and just stick the 2 on. And then obviously that's just 1. So this answer here is 1,200. So yeah, we're right. There are many ways if you're struggling on calculator to compute certain stuff. But yeah, that's the idea of this question with rate. You are, they love throwing these type of questions in, like a 2 marker, quite short, but it's like reverse percentages, right? Unknowns, unknown percentages. And the best strategy, I think, I mean, for me personally, I guess, of some people got freak out, like, oh God, I don't know this. How do I get to this? Like, if but you should know how to work out 20% of a number, right? And which is a fifth. If you just let X be the number, you're basically doing the process, right? So you do a fifth of a number, well then, and then you just solve the equation. So then you times by 5 to get rid of the fraction, and there you are. And that's how you get to that. If you let X, if you just let the initial price that you need to know, just let it be a number, then do it as usual. Okay. But that's one method. Obviously, if you have your own methods, go ahead. But that's one way of looking at it. Hopefully that makes sense. Hopefully you should be able to tackle that question. A question like this will come up, reverse stuff like this. You need to be able to aware to do it for both tiers, okay? If you're struggling with this question, look at reverse percentages. Okay. Now we're on probability. So again for both tiers, Mimi has two bags. In the first bag there were 3 red balls and 7 green ones. In the second bag there were 4 red balls and 5 green balls. She takes at random a ball from the first bag and a ball from the second. Work out the probability. She takes 2 green ones. So this is a tree diagram question because there's essentially two different things going, two different events going on. So obviously the first bag and the second bag, and she can only take a red or a green. Likewise, a red or green in the second one. So what the idea of this offer with probability trees, which you should have revised by now, hopefully. Um, well, we need the probability of each thing. So the probability in the first bag of taking a red, well, we're told there are 3 red balls, so we want to take 3. And in total, there were 10 balls, right? 7 green and 3 red is 10. And so the probability of taking a green should be 7 out of 10, right? Uh, and there's 7 green balls, and obviously 7 out of 10. Okay, in the second one, uh, so we're to- um, so then in the second bag there are 4 red balls, and then the total's gonna be 4 and 5, so 9 balls in total. And then there are 5 green balls, and that's again out of 9 in total. And that's our probability tree. Okay, so now we say we want the probability that Mimi takes 2. So we want probability of 2 green balls in particular. Probability of 2 green. So so what needs to happen is in the first bag she takes a green, and the second one she also takes a green. So remember, when you combining two together, you need to times the probabilities. So the and rule, right? So we need green and a green. So that's going to be, that's 7 over 10. She takes a green in the first bag. And then times the probability of the second being a green one. So that's 5 over 9. So now you just time the fractions together. 5 times 5 is 35. And then 10 times 9 is 90. That is your final answer. You don't need to simplify it. That it doesn't tell you to. That's the final answer. Okay. That should be a fairly standard tree diagram question. Hopefully you're comfortable with that. There will be a probability question on your paper, absolutely. So you need to be prepared to do stuff like this. Hopefully it made sense. Okay, that's the end for height of the foundation tier. However, I will say the next 2 questions you can be asked on foundation. They are foundation topics. They just decided to not ask us on the foundation paper. So if you do still want to stick around, I still do recommend it. It'll be topics you've seen, but I think they might just be a little bit too hard for foundation. But a nice stretching challenge. But you should have learnt these topics. But yeah, this is the first strictly higher question that was only on the higher paper in 2017. Okay, so this is an estimation question, which can be on foundation as well. So estimation, well, it has to be on your non-calculator because your whole idea is estimating stuff without a calculator. Um, and yeah, so that's what this question is getting at. So we need to estimate the height of the cone, but we are given all the formula and stuff we need here, the volume of a cone here. So we know that the volume, well, let's use the formula. So the total of volume is 98. And then obviously that's a third times pi. times radius squared. The Taylor's radius is 5.13 squared times h for height. And that's what we want, the height. However, it says to estimate, and without a calculator, you won't be able to work any of this out. You don't know what pi is, what 3.13 squared is, 90. They're awkward numbers, okay? So we need to estimate these values, pick sensible approximations for 98 and pi and 5.13. Now, actually, they don't tell you what pi is, but you really should know. Pi is 3.14 something. You should know that. I think, no, it won't say on the front of the paper, but you should know that. Okay, it's 3 point something. Okay, so we need to approximate these values and sensible values. So what's screaming here? 98 is quite close to 90 to 100, right? I think 100 is a good guess. Now a third, just leave it there for now. That's a definite number. Let's just leave it there. Pi. Now again, 3.14. I think it makes sense to round to 3. So you could argue maybe round to 5 or something. There might be, they might allow for some leniency on that, but I think 3 is the best guess, and that makes good sense because the 3 will cancel with the third here. Okay, and 5.13, well, it's closest to 5. Um, that's 5 squared, which should be nice, times h. Now we've got nice numbers. Okay, those are the most sensible numbers, I feel like. So now we estimate. So this is estimation by rounding answers as sensibly as possible. Hopefully it makes sense. So now we just carry this calculation out. So 100, so let's simplify this a little bit. So a third times a 3, well, 3, that's 3 over 3, which is 1. They cancel each other out. So then 1 times 5 squared, well, 5 squared is 5 times 5, which is 25. So it's 25 times h. And actually, this is very nice to work out because h is now 100 divided by 25, which is 4. And that is going to be your estimation for the height. Okay. Now it says John uses a calculator to work out the height of the cone to 2 decimal places. So he's doing this calculation here now, the exact numbers. And he rounds it to 2 decimal places opposite the end. It's saying, will your estimate be more or less than John's answer? So is our estimation smaller or bigger than the true answer? Okay. And give a reason. Okay, let's look at what we've done here. We have times pi with the radius, and then we divided. So this is what we've done essentially. So the height is the volume divided by a third times pi times the radius squared. If you rearrange it a little bit, but that's essentially what we've done. If you look here, we have a third times the pi times the radius squared. We did all that. We got 25. And then we divided it by the volume. The volume here divided by all that bit, right? The third pi r squared. Now, what did we do? So, our volume we rounded up. We rounded up. Pi we rounded down. And radius we also rounded down. It went from 5.13 to 5. Okay, so look at this here. Look at what we've done here. Okay, we have if we rounded up the volume, this is going to make the numerator bigger. But also, we rounded down. We made pi and the radius smaller, so we made the denominator smaller. So what we're doing here is we divided a bigger number by a smaller number. Because the volume increased at 98 to 100, and this pi went down to 3, radius went down to 5. So the denominator is smaller and the volume is bigger. So the overall fraction then, so the division, the overall division, is going to be bigger than obviously the true answer, John's answer. Because if you increase the top number and lower the bottom number, so if you increase the top number, obviously that's going to make the division larger. But also, if you divide it by a smaller number, you are going to make it larger as well. So, say for example, if you are struggling to visualize this, try some examples. So, say if you had 50 divided by 4, uh, no, that's not a good one. That 40 divided by 4. So, pick those numbers to test. That's 10. Now, say we increase the numerator, so this was the top number here. Say this went down to 50, and we made the bottom number smaller. So, say this went down to 2. That's going to be now 25. Notice how drastically different and bigger this one is than the other. So, if we make the top numbers bigger and we divide by a smaller number, then actually it's only going to increase the result. So, hopefully that makes sense. And that's what they're getting at. So with these reasoning questions, you've got to really consider what you've done and how that affects kind of the answer, I guess. So think about the calculation here, how that would differ. So this is the height, this is the division here. So it's we've got a bigger number, so that means our estimate has to be larger than John's because of the reasoning there. Okay, hopefully that makes sense. And that was only for 1 mark. But yeah, these reasoning questions will come up as well from time to time on your paper, so it's just good to be aware of. Some people do struggle with it. I use it as well, but that's the idea with these how you approach this sort of thing. Okay, hopefully this makes sense. Estimation would absolutely be coming up on your paper, um, surely, like 98%. I would say 98% chance. Obviously, I can't 100% confirm anything will come up, but out of anything, this will come up the most, I reckon. So it's really good. Again, it's easy. I do think this is quite easy marks if you like this topic. It shouldn't be too tricky, hopefully. Okay, another higher tier question. Again, this can be on foundation because this is standard form, and standard form is a grade 5 topic, which I believe should be on the foundation spec as well. But it's quite tricky for non-calculator. But anyway, so yeah, standard form can also come up on non-calculator as long as they make the calculations fairly simple. So don't throw it away and look, oh, it's only going to be calculator. Or the calculator will just give me it in standard form, so I don't need to learn it for non-calculator or whatever. It's a free month. No, you do need to learn it for non-calculator, and I do predict it will come up as well. I think Edexcel real or whoever realised a calculator makes it a lot easier, so they're going to put it on non-calculator. But even then, if not, it's still good to learn, and you need to learn it for the other papers anyway. Hopefully, you should have learnt it by now. So yeah, so without a calculator, so at part A, write in this as an ordinary number. So that's without no tens, just literally as a decimal or whatever. Well, 7 point. So this should be automatic now at this point to do. But the idea, well, 10 to the minus 6, that's telling us we're going to move the decimal point this way. So we're going to make it smaller, the number. So we're going to, so obviously if you times by tens, that affects the decimal point. So if this is a big number of 10, big power, that's going to make the number larger. So you're moving the point to the right. But the negative means we're making it smaller, we're going to the left. So we need to move the point about 6 points to the left. So it's going to look something like this. Let's test it. So the point was here. How many points do we move? 1, 2, 3, 4, 5, 6. So that we moved it 6 points to the left. That should be your answer here. Okay. Then it says for part B, work out the value of this. Now, again, this is non-calculator. Now, the numbers might look a bit scary, but break it down. So, again, it's a division, so it's always best to write this as a fraction. 10 to the minus 3. Now, there are two parts to this. We want to divide 2.56 and 4. But also, we can cancel the tens. If you remember the power law, a to the m divided by a to the n, you just subtract the powers. So 10 is on both of them, different powers. So 2.52 times over 4 times by 10 to the 5 minus 3. You do two negatives, you add them, so it's going to be 10 to the 8. So now all it boils down to is to working out this calculation here. So with this type of thing with division of two standard form numbers, split it up like this and divide the main number first, and then deal with the 10 power after. Okay. So now 2.52 divided by 4. Well, it's exactly kind of like the first question. You want to divide one number by another. Well, let's get rid of this. Let's get rid of the decimal point. So how do we do that? Well, you're going to move it 2 points, so you're going to times the top and bottom by 100. So that's going to be 252 over 400. Okay. Um. Okay. Now, this number's a bit too. You could do bus stop method, perhaps. However, it's not going to get you far because, well, 252 over 4 doesn't go into it. 252 into 4t doesn't go into it. 252 over 400. Well, it's kind of nothing's changed there really. And you're going to get a huge remainder, and it's going to be really awkward to work with. So, what you should know, how you should simplify this. Well, um, think of keep just simplifying and reducing the fraction down. So, um, clearly they're both even. So let's divide by 2 first by both of them. 252 over 2 is well, we know 250. Half of that is 125. So 100, 252, surely it's 126. And obviously half of 400 is 200. Okay, and then obviously they're both even again, so let's keep simplifying. So that's out of half of 200 is 100 clearly. 126, so half of that is going to be 64, right? No, 63, sorry. 60 times 60, 120, 3 plus 3, 6. So I hope that makes sense. And again, uh, and can we simplify again? Uh, it's going to be quite awkward. Clearly, this is what the top number's not even anymore, but this is. So the factors, if there are any, is going to be quite awkward. But notice this key bit here. We're actually divided by 100 now. This is great news because, again, 63 divided by 100. Well, divide anything by 100 or 10 or 1,000 or multiples of 10. You're just moving the decimal point. So there's a decimal point here. Move it 2 to the left. That's going to be 0.63. So that means 2.52 over 4 is yeah. So this fraction here, this division, is now. So our answer is 0.63, which comes from this fraction here, this division that we just computed, times 10 to the 8. However, it says to give the answer standard form. A standard form is a number like this, a times 10 to the something power n. Now, a has to be between 1 and 10, 1 and 9. So, for example, 3 times 10 to the 6 is standard form, but 0.3 isn't because it's not between 1 and 10, the front number. Okay. So, well, how do we go from so how do we get to the number? Well, we're going to need to move the point to 6.3, aren't we? Times 10 to the 8. Okay. But to get from 6.3 to 0.63, we're going to have to move the decimal point by 1. So 6.3. This is a really tricky question, actually, for non-calculator. 6.3, well, that's 0.63 to get, but we're going to have to times, oh, hang on. No, sorry. The other way around. We want 0.63, but we need to get to 6.3. But clearly, we have to times by 10 to the minus 1, which means we move the decimal point to the left by 1. So we're going to have to tag on a 10 to the minus 1 here. Okay. So this makes sure this is now in standard form because it's between 1 and 9. Instead of 0.63, you have 6.3. But to make sure this is same as 0.63, we need to tag on a 10 to the minus 1, which means our point will move to 0.63 here. Well, we're nearly done. So now we need to bring this 10 together. So again, if you times in, we need to add the powers. And 8 minus 1 is 7. That should be the answer. Quite a lot of marks effort for 2 marks, I must say. If there's a quicker approach, please, well, let me know. Okay. But yeah, this was a non-calculated question, by the way. Wow. Something could come up like this again, like to make the numbers sort of workable. But yeah, that's how you approach this sort of question. Oh, that was intense for 2 marks. Wow. But yeah, they can ask this as a non-calculator. Don't be thrown off though. Okay. Hopefully, it made some sort of sense. Hopefully, but if you practice standard form, you should be used to this type of to doing it this sort of way. Okay. Okay, question 11. Okay, we have an interesting box. And now I've seen basically most papers, they seem to love asking box plots on paper 1. So I expect a box plots question here for 3 marks for. But I picked this question because it's a bit interesting. It's a bit more problem solving. So you might be asked something like this. So we're given a cumulative frequency graph, and we need to use this to draw a box plot. Now, they've already given us the minimum weight is 163 and the maximum 188. So you should know with box plots, the minimum, we draw like a line. So 163 is going to look about here, right? So draw a line then. Okay. Actually, let's make it a bit consistent. Let's do it between the two major lines. 2, 3. Here we are. Right, that's the minimum, and the maximum is going to be over here. It's a bit wonky for my liking. There we are. Right, so the maximum with a straight line, of course, a ruler. That's how you label the minimum and the maximum. But you should know that the major feature of the box plot, you need a min, a max, but you're also going to need a lower quartile, an upper quartile, and a median. But they've given us the min and the maximum, but they're not giving us the quartile, upper, lower, uh, or the median. But what they have given us is a cumulative frequency graph. And you should practice some questions, and you should know how to use a cumulative frequency graph to work out medians and lower upper quartiles. Now, for some reason, upper cumulative frequencies should start at 0. I don't know why. Um, I kind of finished it. I don't know. The graph might be look like that. I don't know. But it should start at 0. I don't know why. The question here from the topic question from Maths Genie, I think Edexcel published it. I'm not too sure, but it is an official question this, but I don't know why. It should start at 0. Um, that's the whole idea. It starts from 0 and then you work your way up to 60. So I'll just continue that off. But obviously, it tells us a total of 60, which you can see here. So the median, you should remember, is half of the frequency, so 50%. Well, that half is 63. So actually, we're going to read off the graph here and get to 30, which is here, which corresponds, make this a bit clearer, and then read off the graph, and it's 170. So the median is going to be 170. Now we need to get our quartiles. So the lower quartile, that's the easiest one. Well, that's 25%. So 25% is a quarter, or 0.25, doesn't matter what. So a quarter of 60 of the total, right? So 25%, well, that's going to be 15th, which is here. And that's going to be down here, which is 165, okay? So the lower quartile is LQ, is 165. And then lastly, the upper quartile. Well, the upper quartile, well, it's 75%, which is 3 lots of 25%. So it's 3 times 15, because the 15 is 25%. So as we get 75 times it by 3. Well, 3 times 15 is 45. Okay. And that's going to correspond to this here, which is this part here. And that's looks like to be 175. Okay, so that's our upper quartile 175. We now have all the information to plot a box plot. So you should know that this then continues the minimum line, and it continues to. Oh God, I got rid of it. I didn't mean to. So the minimum was 163, so it'd be here. There we are. So the lower quartile is 165, so Ellie goes to there. And then we have a box here. And then we need to go towards the median, which is 170. With a nice ruler, of course. So then you draw it up to the median. And then we worked out that the upper quartile is 175. So 175 is there. Draw another line up. A bit nicer than that, hopefully. There we go, 175 there. Draw another, oh God, not a wonky one. Draw another line to connect the box. Draw one there. Oh no, actually, no, you don't do that. And then, yeah, then you connect it to the maximum, okay? Oh, I'm a better line than that. Oh, God. Oh, for God's sake. I want to make it somewhat straight. Come on. There we go. That's about as good as it's going to get. So that's what the box plot should look like. So you should remember by now what a box plot entails. So you're going to need a minimum and a maximum. You're going to need a lower quartile, a median, and an upper quartile. And that's how what a box plot should look like. Okay, I like this question because they don't give you the information you need, and it combines community frequency. This is a very typical exam sort of question. That's how they like to do this sort of thing. Combine topics together, use it with problem solving, find missing information. Okay, hopefully it shouldn't be too bad, but yeah, that's a question like this, a definite question about box plots anyway. I expect will come up. Okay, lovely. Hopefully it made sense. Okay, question 12. Again, they love asking these sort of index questions, like the middle of the paper, just a few marks. Just check you know your index laws. So you should know 36 a half for 1 mark. A half, oh well, the square root of 36, which is just 6. 6 squared is 36. Cool. 23 to the 0. You should know anything to the 0 is just 1. I'm not going to go over that just now, but yeah, rapid fire. And then 27 minus 2 over 3. Again, split this up. So the negative first. So the negative, remember anything negative 1 is the reciprocal. Well, reciprocal 27 is 1 over 27. And that's going to be now 2 over 3 to get rid of the minus. Again, now over 3, do the fraction. You want to cube root it, okay? So cube root the fraction 1 over 27. And that's going to be squared, right? So do the fraction bit first, which is the rooting. And then the top number is squaring it. Well, what's the cube root of 1 over 27? So we can split this up. So cube root of 1 over cube root of 27. So cube root both top and bottom. Well, cube root of 1 is just 1. And the cube root of 7, you should spot, is just 3. 3 times 3 times 3 is 27. And then that has to be squared. Well, square the fraction. So 1 squared is 1. 3 squared is 9. And that should be your final answer. Okay, hopefully it made sense. They love asking questions like this. Absolutely, again, it'd be a non-calculator because obviously, if it was a calculator, you could just plug this in. This is a good. They just love throwing questions like this in to make sure you know your index laws, which hopefully should be aware of by now. But this should be a little refresher. Okay, if you're stuck on stuff like that, make sure you practice it quickly before the exam. Okay, question 13. We just got about halfway. Again, they love asking these sort of line questions as well. So you need to do a bit of problem solving here. So the equation of so we're given equation of two lines, L1, L2, and we are given that L1 is perpendicular to L2. They love doing this to make sure you can manipulate the gradients, stuff like that. So a bit of algebra here. So find the value of k. So what does it mean to be perpendicular? Well, you should know that if they're perpendicular means the gradients are negative reciprocals, okay, of each other. So then what this means is we need to find the gradient of L1 of both the lines even. So the gradient of L1, well, y is mx plus c. It's in this form. M's the gradient here, so the 2, the number in front of the x. So that's 2. Now actually we should know then the L2 gradient because they're perpendicular. Well, that's going to be minus a half. Because you take the reciprocal, 2 reciprocals are half, and then minus it to make it negative. So minus a half. Okay. So we know what the gradient of L2 is, but we also know how to find the gradient of a line. Write it in this form, y is mx plus c. So 6y plus kx, and we're given the equation of L2 here. So 6y plus kx minus 12 equals 0. Let's try and write it in this form here, like L1, y equals, so we can compare. So therefore, 6y rearranged on the other side. It's going to be minus kx plus 12. Subtract kx from both sides, add 12 to both sides. 6y is this, so that y divide by 6. So minus k over 6x plus 12 over 6, which is 2. 12 divided by 6 is 2. Hopefully that's clear. Well, now this is in the form mx plus c, right? So the gradient m has to be the same gradient here, minus half. So now we solve for k. So I guess you can get rid of the fraction, the negatives, both negatives. So then k, well, k is going to be 6 over 6 times a half, right? Get rid of the 6 of the fraction here. Times 6 both sides. Well, 6 times a half. Half of 6 is 3. That's going to be your answer for 3 marks there. Again, make sure you're really proficient, especially for higher tier, if you want those top grades. Make sure you're really proficient and you can do it automatically almost, these type of questions. Like, they're pretty standard, like line questions. They give you information about the gradient, so it's perpendicular or parallel. And you can use that to do some algebra to find some missing values. Okay, very typical sort of working out this is. Hopefully that's clear. Okay, on question 14, we have a counting question. So the menu in the restaurant has starters, main course, and desserts. 5 starters, 12 main courses, and X desserts. And there are 420 ways of picking a starter, a main course, and a dessert. Find X. So it's a counting question because we need to find combinations of different ways of choosing stuff. So with for GCSE anyway, the main idea is to separate it into lists. So a starter and a course and dessert are 3 different lists. So the total amount of combinations, which we've given is 420, you times how many things are in each list. So 5 starters, and then we could choose from 12 main courses from the other list. And we could choose from X desserts, which is just X. Okay, so it's just product, right? You times all the options together. Okay, that's really all you need to know for GCSE. Okay, so let's simplify it. So what's this equal to? So 5 times 12, we can simplify this. 5 times 12 is 60. 60 times x, cool. 420. Now to get x, solve x. Well, you want to divide, right? Get rid of the 60. We do times 60 here. We want to divide by 60 to get rid of it. So then 420 over 60 is simply x. Now, what is this? So how many 60s going to 420? 60, 120, 180, 240, 300, 360, 420, which is 1, 2, 3, 4, 5, 6, 7, right? If my mental math is correct. Cool. So that's for 2 marks. Again, they just love asking these sort of combination questions for a few marks. Again, as long as you know to times them, it's pretty bad. You don't want to lose marks like this. Not really, if you can avoid it, especially for those top grades. Okay. Fairly standard combination question. It's a little throw this in. But yeah, mate, I've seen it on a lot of paper ones, so just make sure you're ready for it if it comes up. Okay, hopefully it makes sense there. Question 15. Okay, exact trig values, which I think a lot of people hate. Again, so I'll read the question. Exact value of tan 30 times sine 60, which did come up in paper 1. Give it in simplest form. Now, if there's still any foundation people watching, this can't actually be a foundation question. I'm going to be brutally honest here, even for both papers, I guess, but especially for foundation, it can be very tricky. So 2 marks lost is not the end of the world here. These exact trig questions will not be for many marks. It won't be over 2. So if you're really struggling to revise, like learning them all, it's not the end of the world. However, there is a method I'd like to go over though, and I keep going over, and it's the hand method. So this is only on the higher paper though, in this instance, because there are surds involved, but we'll get into that in a minute. So the exact value. So you want to find the exact value of each of them. So tan 30. First of all, so you should know the obviously the you should know 0, 30, 45, 60, and 90 degrees. So I like to obviously some people use the triangle method, and I'll go over the triangle method actually. But what you want to the way I like to learn, I've learned it for years now, even 8 years, 10 years, whatever. About that, and I still remember them like the back of my hand, pun intended, because we're about to draw a hand. So the way you can learn them, this is the way I like to learn it. It's the hand method. So draw a hand, and can never draw a good hand. Never ever. Okay, that's believe me. If your hand does go like this, please seek medical attention. But you want to start it with 5 parts, 5 fingers, right? And you want to label each finger at 0 degrees, 30 degrees, 45 degrees, 60, and 90. Cool. So it's hand 30. So you use the hand. You can work out sine and cos. So you'd know sine 30. You'd how many fingers you move. Uh, how many fingers you move from the starting one to 0 or whatever. To get to that angle 30. So sine, for example, sine 30. Well, you move one finger. So that's and you square root it. So it's square root 1/2, which should just be half. If you wanted cos 30, you go the other way. So it's kind of like anti-clockwise, I guess. No, clockwise. So C cos for clockwise. Okay, sine is anti-clockwise. So you start from here and you go that way, and you go that way. Cos is anti-clockwise, so you start here and move away the other way, and it must start at 90. So sine 30, for example, would be root of how many fingers from the start? So 1. So root 1/2 over, which should just be 1/2, a half. And then, for example, cos 30 would start the other way. So you start at 90. So then you want to get to 30. You move 1, 2, and 3 fingers. So that'd be root 3/2, which you can't simplify. Now for tan, and then I'll just explain very quickly. Like, I have done a video on this in more depth with loads of examples, but this is just a quick go through. Um, but if you want to use tan 30 or tan of any of these angles, you divide sine by the cos of the angle. Okay, so sine 30 over cos 30. Now, this is why it's good. So you work that sine 30, which is a half, all over cos 30, which is root 3/2. So you divide the sine 30 part by the cos 30 part, which we've worked out. Now the 2's will cancel, so you're left with 1 over root 3. Now actually, rationalise this. So root 3/3 is root 3/3. We do not like surds on the denominator. Okay. So that's tan 30, which is root 3/3. Now sine 60, we need sine 60 now. So sine 60 again should be a bit easier actually. Use this approach again. So starting from 0 because it's sine, going anti-clockwise. How many fingers do we need to get from 0 to 60? Well, go 1, 2, 3 fingers. So it's root 3 using this rule here. Oh god, root here. Root fingers moved, so root 3 because we moved 3 fingers to 60 over 2, and that's your answer there for sine 60. Uh, so therefore, the product, the value of tan 30 times sine 60 times these two together, so root 3/3 times root 3/2. So actually, you're doing root 3 times root 3, which will just be 3. Okay. And 3 times 2 is 6. Now, actually, in its simplest form, we can simplify this fraction. You should notice this is a half. Uh, 3 goes into 6 twice, so there we are. And that should be your exact value for that. So it's really just assessing, do you know, a bit of surds as well, but it's mainly assessing, do you know your values? Again, it's only 2 marks, but there are various methods. Now, if you do not like the hand method, I personally recommend it. But what you can do instead is remember certain triangle. A right angle triangle in particular, always right angle, and always the hypotenuse is 1. Um, so what you want to do then is, what's your angle here? So say for example 30. So tan, if you want tan 30, well, you should remember. Okay, hopefully, I'm gonna move this now. I'm gonna do an alternative method. Because I think a lot of people know the triangle method, or the so-called anyway. Okay, I'm gonna do it this way, but hopefully that. Oh God, but that's the hand method. Obviously, if you want, if there should be videos online on YouTube about the hand method. If you just type it up, hand method trick or something like that. But that's the hand method. I've done also video on it, on my in another revision video. But yeah, anyway. Um, so the idea with triangles, remember a right angled with hypotenuse 1. That's what you need to remember. Then the angle is whatever angle you have, so 30. And so then use Sokotoa, which hopefully you should remember at this point. And this will be for both, even foundation and higher, you need to remember Sokotoa. And you also, for both foundation and higher, you need to know your values as well, but as with higher. Now just use trig. So obviously tan, you need the opposite, which is here, and the adjacent, but we don't know either. But we can use one of these because we know the hypotenuse to work out either, and then to work out the missing values. So we know opposite is going to be sine 30. Oh, actually, no, ah no, because we want to find the opposite, but we want to find sine 30, don't we? Um, no, I don't think we can. No, with this method, we'd need to know the opposite and adjacent. I don't know. Maybe I can't remember. See, this is why I don't do the triangle method. You need to know. You need to know specific values for it. I can't remember what they are. Um, but the hand method is very simple. You know what I mean? All you need to remember is just to put the numbers in, and just remember this: root finger over 2. There are no actual values you need to remember, really. That's the beauty of it. But with I don't get what people love the triangle. I think you need to remember certain values, and there's like 2 different triangles. Because opposite what? Be sine 30 over 1. Well, opposite sine 30. But what the hell is sine 30, you know? Okay, but that'd be like what, sine 30? Tell you what, I'm going to leave it there. I might come back to it later, but okay, let's move on. But that's one method anyway. As long as you have your method for learning the ratios, like the Hatter method for me, that's the answer. That's how you do it. But yeah, that's 2 marks. Okay, we'll leave that there for now. Again, algebraic proof. Again, it will always look like this. They often comes up as well on paper 1. I've noticed. So yeah, and it also these always follow the same sort of approach. At least for GCSE, always the same approach. You basically pretty much always want to consider odd numbers, which would look like 2k plus 1. Uh, or no, 2k minus 1. It doesn't matter. 2k, you can have 2k minus 1 or 2k plus 1. But k is an integer, right? K is a whole number, an integer. That's what integer means. And you need to know even numbers are simply a multiple 2k. K is an integer. And every even number is obviously multiple 2. So then if you add or minus 1 to that, that'll give you an odd number. That's where that comes from. Anyway, so prove algebraically the sum of squares. There's a lot going on here. Sums of squares of any two consecutive even numbers is always 4 more than the multiple 8. Wow. Okay, but let's break it out. So the sums of the squares of any two consecutive odd even numbers. So we'll work our way back. So what's two consecutive even numbers? So an even number would be 2k, but then a consecutive one, the next even number would be 2k plus 2. So, for example, 2 would be an even number, then 4 would be the next even number. So it's asking for the next. Consecutive means the next one. Okay. So 2k, then you have to add 2 to get to the next even number. So if 8's an even number, so is 10, so we add 2 to it. Okay. Okay. So those are two consecutive even numbers, consecutive even. Now it's saying for the sums of the squares. So now we need to square them and add them. So 2k squared is going to be 4k squared. So 2 squared, which is 4k squared. And 2k plus 2 squared, which is going to be harder. Well, you expand the bracket. So you should know if you square, that's the same as times it by itself. So it's a bracket repeated, like so. And now you just simply expand it. So you can use FOIL or whatever you do. So 2k times 2k is going to be 4k squared. 2k times 2k times 2, which is 4k. 2 times 2k is another 4k. And 2 times 2 is 4. And let's just simplify that. So 4k squared plus 8k plus 4 by just collecting like terms. Okay, that's just expanding. Again, make sure to just to emphasize, if you're squaring a bracket to expand, repeat the bracket. That's what it means. Okay. So now we've worked out the squares of the two numbers. Now we need to sum them. So the sum is going to be 4k squared plus for this number, and then we add in this. So 4k squared plus 8k plus 4. Well, collect like terms of 4k squared, 8k squared, plus an 8k, plus a 4. So that's what we've done. So now we say that the sum here is always 4 more than a multiple of 8. So the strategy is consider odd and even and factorise to get a multiple out. Well, 4 more than the multiple of 8. Well, we're adding 4 here. And actually, these we can factorise to get 8 out, can't we? 8k squared plus k. So this is an integer. So 8 times a number, that's a multiple of 8. So so that's our proof. So that's it, right? So multiplying. So we get, okay, let's rephrase. So we get uh, a number, which is the bracket, k squared plus k. So we get an integer, a whole number, multiplied by 8. Then we add 4. So that's our proof done. Right, obviously for GCSE, they don't expect too much, but yeah, that's the gist, right? So, because yeah, I picked the hardest one there as well. So there's a lot of stuff there, but it's a good learning curve. I like this question. Obviously, some people probably don't, but I like it because it shows a lot of stuff off. So that's the idea. Again, you should have practice proof. They follow the same sort of format. Some a bit more lengthy than others. This one's a bit on the hard side, but it's the same sort of approach. So consecutive means you need to consider the next one, and consider odd and even numbers. So this is what we've done there, and it will often come down to expanding a bracket because we're squaring, and then factorising to get multiples. So that's our answer here. So because of all this, we indeed show that this sum here is four more than a multiple of 8. Because we multiply by 8 here, so it's a multiple of 8, and then we have 4 more. Okay, so we add 4. Hopefully that's clear. That's only 3 marks though. Okay, question 17. We're nearing towards the end. Or question 17. Okay, so we have again. They love asking these. I've noticed they love asking proportion questions, but they love combining them together. So there's inverse and direct proportion. And they love combining them together like this. I've noticed questions like this tend to come up, so it's very good to practice them here. So there's two bits of information going on here. So y is inversely proportional to d squared, and then we're given information here. So let's split this up. Let's work it one by one. So firstly, y is inversely proportional to d squared. People, as simply as possible, all that means is it looks like this. When you have two variables inversely proportional, so y and x, for example, it looks like k over x. That's all it is. It's 1 over x times the constant k. Direct proportion, it's just simply kx. That's all it means. So that's what we're doing here. Y and d squared, inverse proportional, switch x to d squared, is k over, that's inverse proportion. You can do this little symbol here, it's, you don't need to. Just simply that, when you say it's inversely proportional, just write this down. It looks like this. Okay, k over something. That's all it is. Okay. And so now we're given this because we need to find this constant here. D is 10, y is 4. So what we're going to do is substitute it into there. So that means 4 then, y is k over 10 squared. Which is 4 is k over 100, right? So that means k is going to be, get rid of the 100, times 100 both sides. It's 4 times 100, right? Which is 400. Which therefore means y is 400, because that's k, over d squared. Okay, now we deal with the next bit. So d is directly proportional to x squared. So like I said, it's direct proportion just means it's a constant m x squared. Okay, so the m's the constant here. So it look yeah. So x squared here, so direct proportion. So we times it by a constant. So the divide we have a multiple here. Okay. Um yeah, so and then in the exact same way we're given information. So we know that x is 2, d 24. So substitute it into here. So 24 then is m times x squared, which is 2 squared. So 24 then is 2 squared is 4, so that's 4m. So then a constant m, or 20 divided by 4, 24 divided by 4. Well, that's going to be 8. No, no, 6. I was thinking something else there. No, 6. Um, yeah. So that means then D is 6x squared. Okay, hopefully so all we do now in direct inverse proportion. You know, you should at this point hopefully you should know how to work out inverse and direct proportion of values and stuff like this. This should be pretty standard, right? You might have done it with only one in one type of thing, but you're just splitting it up and doing it twice. That's all it is. None of this, hopefully, for practice, especially with the high grades, this shouldn't be unfamiliar, right? You should be pretty quick with doing this, hopefully, okay? But that's the main bulk of it. But now it's said, find a formula for y in terms of x. So we need to find y in terms of x. But y here is, in terms of d, it's 400 over d squared. But actually, we know what d is as well. D is in terms of x here, so we can substitute it in here. So 400 over d squared, well, d is this, d is 6x squared, so d squared is 6x squared all squared, which is 400 over 36, 6 squared is 36, x squared squared, that's x to the 4. If you're unsure, well, if you remember this power law, am to the n, you times the powers, which you've got here. Okay, 2 times 2 is 4. Okay, that's y in terms of x now. Let me make that a bit clearer. However, it says to write in the simplest form, which means we need to simplify the fraction. Well, 436. Let's do it up here. Okay. Well, let's. We know they're both even. Let's simplify. Divide by 2. That's going to be out of 36 divided by 2 is 18. 400 divided by 2 is 200. Again, they're both even. Divide both sides. 9 over 100. And there's nothing you can do here. And we can't simplify this anymore. Okay. Because 9, well, not much goes into 9. 9 doesn't go into 100. 3 doesn't go into 100. So that's it. So we can't do anything more with this. So actually, our simplest answer is y equals 100 over. I want to make this clearer. Our answer then here, I write it here. Y is 100 over 9x to the 4 at the bottom here. Okay. And that is going to be your final answer for 5 marks. Okay. They love asking this type of question. I've noticed in lots of past papers. Stuff like this, exactly this form of question, right? Given two different situations, you have to find a formula, combine them. So you do two separate proportion questions and then combine them. Okay, but hopefully it makes sense. So hopefully if you practice a lot, this shouldn't be too much of a surprise, right? This shouldn't be too like, oh, what do we do here? Hopefully, again, just break it down. Like you see all this, oh God, break it down into two. And you should know how to do direct and inverse proportions separately on its own. It shouldn't be new, hopefully. Finding k here for y and d squared, finding n the constant, d and x squared. You should know how to find a formula for y and d squared, d and x squared, and yeah, combine them. Okay, and hopefully that should make sense now. Obviously, reach out if it doesn't, but that shouldn't be too bad if you know your proportions. Okay. Okay, question 18. We are again functions question also loves to come up. Um, they love asking function questions. So inverse and composite functions for higher tier. Okay. So we're given two functions. What to find? Firstly, G inverse. Very standard questions these are. So I'm not going to explain about inverse too much, but all you need to know is essentially x and y flip. Flip sides. So the aim of this is if we say y is g of x, so that means y is root x plus 2 over 5. We want to switch y and x, so we need to rearrange so x is in terms of y. So we need to get x on its own here. So we're just rearranging, and it's only 2 marks, a fairly simple one. So how do we get rid? Well, we've rearranged with fractions. We want to get rid of the fraction. So 5y, if you times by 5 on both sides to get rid of it, that's root x plus 2. And then to get root x on its own, minus 2 to both sides. So root x is going to be 5y minus 2. And so then to get x on its own, because it has to be x not root x has to be the square of this, okay? And you don't have to expand it, it's only 2 marks. It doesn't say to write it in a particular form, it's fine to leave it like this. And so then G inverse then, because now x is, the roles are switched, x, because that's inverse, that's the idea of inverse, you switch the roles, y and x. That's our function, right? So 5x minus 2, make sure it's not y here, but x, because we're plugging in x here, even though we switched them, we need to make sure it's still x at the end here. So that is our answer here for 2 marks. Okay, hopefully it made sense there. You don't need to expand it, it's fine. Okay, for part B then. Solve gf of x is 3. Bear it now, you must remember this is a composite function. So we're substituting one function to another. So this is saying g of f of x. There's a missing bracket there for g. Okay. This is not saying g of x times f of x. That's not the same thing. Okay. It's g of f of x. Notice there's no bracket after the g. So that means we're substituting f into g. There's like a hidden bracket here. Okay. You just need to be aware of that if you practice. That's composite functions. Okay. Okay, so that's what we're going to do. So g of f of x. Well, what is f of x? 3x plus 4, and we plug that into g. And so f of x is here, and we literally plug it into g here. And so then 3x plus 4. So g of x, so g of 3x plus 4, in place of x is now 3x plus 4. So that's going to be root 3x plus 4 plus 2 over 5. We are told this is equal to 3. Oh god. 3x plus 4 plus 2 over 5. We are told this is equal to 3. Because we're told this g of f(x) is equal to 3. So now we solve x. So it's just an equation, right? So again, get rid of the fraction by times in by 5. So 5 times 3 is 15. So that means then root 3x plus 4, subtract 2, both sides is 13. Then you want to square both sides to get rid of the square root. That's 13 squared. Now 13 squared is 169. Just a little note there. 30 times 13, 169. If you're unsure, just do a quick long multiplication. I'm not going to do it here, but that's how you can work it out with a bit stuck. But yeah. Oh god, what's going on here? Yeah. It won't let me rub it out. Yeah. What's going on? Oh god. It won't let me rub it out. I don't know, it must be buggy or something. Okay, but yeah. You need to know that 13 squared is 169. Let me just save actually.